In April of 2025, headlines around the world started using a specific number to describe a distant planet called K2-18b, a 99, 7% chance of life. That number spread everywhere, repeated in videos, articles, and social media posts, as though scientists had essentially confirmed we're not alone in the universe. Here's the problem. That's not what the number actually means, and the scientist who led the original research never claimed it was. Before we go any further, I need to walk you through what that 99.7% figure genuinely represents, because understanding it properly is actually a far more interesting story than the misleading version that went viral, and it tells you something important about how real scientific evidence gets twisted on its way to becoming a headline. This is the true story of K2-18b, the actual statistic behind that number, and what's happened to this claim in the time since. If you want the accurate version of stories like this, instead of manufactured certainty, subscribe now, because this story isn't finished yet. It also helps to understand exactly how Webb manages to study the atmosphere of a planet sitting more than 100 light years away in the first place, because the method itself explains why teasing apart one specific molecule from another turns out to be such a genuinely difficult technical problem. K2-18b periodically passes directly in front of its star as it orbits, a transit that causes a tiny, precisely measurable dip in the star's overall brightness. As starlight passes through the thin ring of atmosphere surrounding the planet's edge during that transit, specific wavelengths get absorbed by whatever molecules happen to be present, leaving a kind of chemical fingerprint embedded in the light that eventually reaches Webb's instruments. By measuring exactly which wavelengths are missing or dimmed, researchers can work backward to identify which molecules are present and roughly how abundant each one is. It's an extraordinarily indirect measurement, reading a faint chemical signature encoded in starlight that's traveled over 100 light years and briefly filtered through an atmosphere thousands of miles away, which is exactly why distinguishing dimethyl sulfide, specifically from other molecules that happen to absorb light at similar wavelengths, has proven to be such a genuinely contested technical challenge. Let's start with the planet itself, because K2-18b has been a genuinely interesting target for exoplanet researchers for years, well before any of this controversy began. It orbits a small, cool, red dwarf star called K2-18, sitting in the constellation Leo, roughly 124 light-years from Earth. A distance so vast that even traveling at the speed of light, a message sent today wouldn't arrive for over a century. The planet itself is considerably larger than Earth, with a radius a little over twice our own planet's, placing it in a size category astronomers call a sub-Neptune, a class of planet with no direct equivalent anywhere in our own solar system. What made K2-18b interesting in the first place is that it orbits squarely within its star's habitable zone, the range of distance from a star where temperatures could theoretically allow liquid water to exist. Back in 2023, a research team led by Niku Madhusudan, an astrophysicist at the University of Cambridge, used the James Webb Space Telescope to study K2-18b's atmosphere directly, confirming the presence of methane and carbon dioxide, and notably finding no ammonia, a combination that led the team to propose K2-18b might belong to a theoretical category of planet they call a Hycean world, a term combining the words hydrogen and ocean, describing a planet with a thick, hydrogen-rich atmosphere sitting above a genuine global ocean of liquid water. That same 2023 paper included a very weak, low-confidence hint of a molecule called dimethyl sulfide, often abbreviated DMS. On Earth, dimethyl sulfide is produced almost exclusively by marine life, primarily phytoplankton in our oceans. The signal was far too faint in 2023 to draw any real conclusions from, but it was enough to justify a closer look. If a story built on tracking real science accurately rather than repeating a viral headline is the kind of thing you want more of, drop a like on this video right now. It genuinely helps this content reach more people who'd get value out of it. A closer look came on April 17th, 2025, and this time the signal was considerably stronger. Using Webb's mid-infrared instrument to gather new data across a different portion of the light spectrum, Madhusudan's team reported detecting spectral features consistent with dimethyl sulfide, and possibly a related compound called dimethyl disulfide, at a statistical confidence level described as 3 sigma. And here's exactly where that 99.7% number actually comes from, and exactly what it does and doesn't mean. In statistics, sigma is a measure of how unlikely it would be to observe a particular signal purely by random chance if there were actually nothing real there at all. A 3 sigma result corresponds to roughly a 99. 7% confidence that the specific pattern detected in the data isn't simply random statistical noise. That's a genuinely notable result worth taking seriously, but look closely at what that percentage is actually attached to. It's a confidence level about whether a specific chemical signal is real, not a probability that life exists on the planet. Those are two completely different claims, and conflating them is exactly how 99.7% confidence the signal isn't noise turned into the viral inaccurate headline, 7% chance of life. Even if the chemical detection itself turned out to be perfectly real and fully confirmed, dimethyl sulfide can, at least in principle, be produced through non-biological chemical processes under the right conditions, meaning a confirmed detection wouldn't automatically prove a biological origin at all, a distinction the original research team was careful to make, and that got lost almost entirely in translation once the story went viral. If you found this distinction more interesting than the original headline, drop a comment and let me know. It genuinely helps me figure out what to cover next. It might help to put those sigma values in a more everyday context, because the jump from sounds impressive to not yet a discovery genuinely confuses people encountering this kind of statistic for the first time. A 2 sigma result, roughly 95% confidence, is about the threshold many medical and social science studies use to call a result statistically significant, and even results at that level frequently fail to hold up when other researchers try to reproduce them. A 3 sigma result, the level actually reported for K2-18b, pushes that confidence up to 99. 7%, genuinely stronger, but physics and astronomy specifically hold themselves to a much higher 5 sigma bar precisely because researchers in those fields are often testing enormous numbers of possible signals across huge datasets, and even a genuinely rare 1 in a few hundred coincidence becomes almost inevitable somewhere across that much data, if the bar for calling something real isn't set high enough. That's not physicists being unusually stubborn or overly skeptical. It's a hard-earned lesson from decades of 3 sigma and 4 sigma results in particle physics and astronomy that generated genuine excitement at the time, and then quietly disappeared. Once more data came in, exactly the pattern that's now played out with K2-18b's dimethyl sulfide signal as well. It's also worth understanding why 3 sigma, despite sounding impressively close to certain, doesn't meet the bar physicists actually require before calling something a confirmed discovery. Physics and astronomy traditionally require a 5 sigma threshold before a result gets treated as settled, corresponding to odds of roughly 1 in a few million that the pattern is a statistical fluke rather than a genuine signal. 3 sigma results absolutely get published and taken seriously as worth investigating further, but they represent a starting point for more scrutiny, not a finish line. Madhusudan's own team was upfront about this distinction from the very beginning. In coverage from the BBC at the time, Madhusudan himself was quoted describing the result as the strongest evidence yet that there is possibly life out there, while also stating plainly that confirming the signal would realistically take another 1 to 2 years of additional observation. That's a scientist expressing genuine, careful optimism about a promising lead, not announcing a confirmed discovery, a distinction that matters enormously and that almost none of the viral headlines actually preserved. Other scientists involved in or reacting to the research were even more direct about the remaining uncertainty. Dr. Subir Sarkar, an astrophysicist involved with the research, was quoted cautioning that while the findings suggest K2 or 18b could have an ocean potentially full of life, researchers simply don't know for sure, urging people to keep watching for further developments rather than treating the result as settled. Avi Loeb, the Harvard astronomer, was blunter still in comments to CBS News, explicitly noting that the same dimethyl sulfide molecule has actually been detected on comets that clearly have no life on them whatsoever, meaning its presence, even if fully confirmed, could plausibly reflect geological or chemical processes entirely independent of biology. These weren't dissenting outsiders trying to tear down an exciting discovery. This was the actual scientific conversation happening around the announcement in real time, considerably more measured and careful than the 99.7% chance of life framing that ended up spreading across the internet instead. The High-Cian hypothesis itself, separate from the specific dimethyl sulfide controversy, has also faced serious scientific pushback worth understanding honestly, since it's the underlying planetary model this entire story depends on. Several independent research groups have published modeling work arguing that K2-18b's deep interior might not actually support a stable liquid water ocean the way the High-Cian concept requires. Under the intense pressure that would exist deep beneath a thick hydrogen atmosphere on a planet this size, some researchers have proposed the interior could instead be dominated by an extremely hot, high-pressure magma ocean rather than anything resembling a habitable liquid water sea. Madhusudan's team has published responses defending the concept's plausibility given the currently available data, but it's a useful reminder that even the basic planetary picture behind this entire story, separate from the specific biosignature debate, remains a genuinely open and actively contested question within the field, layered underneath the even more contested question of whether dimethyl sulfide is really there at all. And pursue that further scrutiny, other scientists absolutely did. Exactly the way science is supposed to work. Just months after the April 2025 announcement, a team led by Michael Zhang at the University of Chicago published an independent reanalysis of the same underlying data and reached a considerably more cautious conclusion, arguing that the specific spectral signature attributed to dimethyl sulfide sits in a region of the infrared spectrum where several other, far more mundane molecules, including simple hydrocarbons like ethane, produce very similar signals. A separate reanalysis, led by Luis Wellbanks at Arizona State University, dug back into the original 2023 dataset that first hinted at DMS and described the earlier tentative signal as essentially a false alarm once properly reanalyzed, with a broader set of possible molecules included in the modeling. And a NASA-led analysis made public in July of 2025, examining the full combined dataset across all of Webb's relevant observation modes, confirmed the planet genuinely has a complex, water-rich atmosphere, but found no conclusive evidence for dimethyl sulfide at all. Additional reanalysis, work published through the early months of 2026, has continued reaching similar conclusions, finding the evidence for both dimethyl sulfide and its related compound insufficient once the complete body of data is considered together rather than any single observation examined in isolation. There's a broader reason this specific miscommunication is worth taking seriously beyond just this one planet, because the same basic pattern, a carefully hedged statistical result getting compressed into an unqualified viral percentage, plays out constantly across science, reporting on genuinely important topics well beyond exoplanets. Medical research, climate science, and public health findings all regularly get communicated with the same kind of statistical nuance that K2-18b's original announcement actually included. Confidence intervals, sample sizes, acknowledged limitations, explicit calls for further research, and that nuance just as regularly gets stripped away somewhere between the original paper and the headline that ends up reaching most people. Learning to recognize the difference between "we're 99", 7% confident this specific signal isn't random noise, and there's a 99.7% chance of the underlying dramatic conclusion is a genuinely useful skill that applies far beyond a single distant planet, and K2-18b happens to be an unusually clean, well-documented example of exactly how that kind of distortion actually happens in real time. So where does that leave the actual current, honest status of this story, as opposed to the number that went viral back in April of 2025? The methane and carbon dioxide detections from the original 2023 observations remain solid and largely uncontested. K2-18b's classification as a genuine candidate for a Hycean world, potentially hosting a liquid water ocean beneath a hydrogen-rich atmosphere, also remains a live, interesting hypothesis, even though that specific interpretation has faced its own separate challenges regarding whether the planet's interior would actually support a stable ocean rather than something closer to a deep magma layer. What has specifically not held up under continued independent scrutiny is the claim of a confirmed biosignature detection. As it currently stands, the responsible summary is that Madhusudan's team detected a real, statistically notable signal, proposed a genuinely exciting interpretation of what it might mean, reported their confidence level honestly as 3 sigma rather than overstating it, and multiple independent research teams have since found that signal considerably less convincing than it first appeared, with some concluding it may not represent dimethyl sulfide at all. It's worth being direct about how a legitimate, carefully hedged scientific result turned into a viral, misleading headline, because that transformation itself is worth understanding. A 3 sigma statistical confidence about a specific chemical signal got compressed, somewhere in the retelling, into a flat, unqualified claim about the probability of life itself, stripping away every layer of nuance the original researchers had carefully included. Headlines calling it the strongest evidence yet for life weren't technically false, and that specific phrase actually did come from members of the research team. But strongest evidence yet is a comparative statement about the state of an ongoing scientific search, not a declaration of confirmed discovery, and that distinction simply doesn't survive the trip from a careful academic press conference to a shareable headline built around a single, misunderstood percentage. None of this means the search on K2-18b is finished. Webb is expected to continue gathering additional data on this specific planet, and researchers across every side of this debate have been explicit that more observations, using different combinations of Webb's instruments and covering additional wavelength ranges, remain exactly what's needed to eventually settle the question. Madhusudan's team has also indicated they intend to investigate whether dimethyl sulfide and its related compound could plausibly form through purely non-biological chemistry at the concentrations being discussed, an important question regardless of whether the original detection ultimately holds up, since even a fully confirmed detection wouldn't automatically prove a biological origin unless non-living explanations could be reasonably ruled out first. So, what does all of this actually add up to? James Webb did detect something genuinely interesting in the atmosphere of a planet sitting in its star's habitable zone, a planet that remains a serious candidate for hosting a global liquid water ocean. What it has not done, despite what the viral 99.7% figure implied to millions of people, is confirm a 99.7% chance that life actually exists there. That number describes statistical confidence in a chemical signal, a signal that multiple independent research teams have since found considerably less convincing than it first appeared. The honest version of this story is less immediately dramatic than the viral headline, but it's also a far better demonstration of how real science actually works. Careful, self-correcting, and built on a distinction between statistical confidence and biological certainty that matters enormously, even when a single misunderstood percentage makes for a much better headline than the truth does. There's something worth sitting with in how this particular story actually ends, at least for now, because it isn't really a story about a discovery being disproven or scientists being wrong. It's a story about a number doing exactly what a good headline number is supposed to do: travel fast, grab attention, and get shared millions of times while quietly leaving behind almost everything that made it scientifically meaningful in the first place. The real K2-18b story was never as simple as a single percentage attached to the word life. It was always a careful, ongoing, genuinely uncertain scientific investigation, and understanding it properly means sitting with that uncertainty rather than resolving it into a number that was never actually true in the first place. If stories like this, the complete and accurate version rather than the number that got the most shares, are what you come here for, subscribe to this channel and turn on notifications, because K2-18b is still being studied, and there's a real chance new data eventually settles this question in one direction or the other. Thanks for watching, and I'll see you in the next one.